let's go back to new problem. Largest prime factor. The prime factors of 13,195 are 5, 7, 13, and 29. What is the largest prime factor of the number big, big, big? Alright, so we need to implement largest prime factor for some number. Prime factors. What is the largest prime factor of the number? Largest prime factor. Alright. For some number n. Okay. So how do we determine prime factors in maths? So a prime is a number that is only divisible by itself and 1. And each number is either prime or consists of multiples of prime, right? So like 5 times 7 times 13 times 29 is this number. Alright. So maybe we should Google just a little. Number into prime factors. Prime factorization calculator. Methods. Prime factorization is a way of expressing a number as a product of its prime factors. A prime number is a number that is... I remember this this problem, we always said it on the test as the last problem we were writing C on paper in my high school. And we always got this problem, and usually nobody solved it. Maybe one or two people. So like 40, which is an even number, its factor is definitely 2. And in the end you get a... So we can start dividing it with small prime numbers, or rather try to divide it, see if it works. And then if it works, we get a smaller number. And then if we can't divide it by like 2, 3, 5, 7, 11. How many primes should I take into account? So as far as I see, the method here is like going with smaller prime numbers and getting to bigger ones until you reach 1, and then that is the largest prime number here. Okay. So we can have something like a prime function, which will be a recursive function, and it will have the number we're dividing, and it will have the first prime number to try to divide it to. And so we have a number and division, Pn, let's call it, it's a prime number, and we try to divide n with Pn, and if the remainder is 0, so it is divisible by that prime number. In that case, what should we do? We should divide the number and leave the prime, right? So like division in Elixir, function div returns an integer, which will be an integer if it is divisible, so that's fine, we can use div. So we can call prime again and use div on npn, return that division, and then return the same prime number. Okay, but in case that this prime number doesn't divide our number, then we have to get the next prime number. So we'll call it again here, leave the number as it is, but get next prime on pn. We gotta implement that as well. Alright, how would we get the next prime number? Uh, how to check if number is prime? Know whether a number is prime.
So
Maybe we can send here like the next biggest number, and then if that number, remainder of that number, division of 2 equals 0, or number 3 equals 0, then it's not prime. Or in our case, it would be 3. So it would be 0. Yeah, that's not good. Is prime. Oh, something like this, yeah. For e in range 2 to number -1, if a modulo that e equals 0, break, print prime break. Right. Ah, yeah. So that makes sense. So we can make a range between 2 and, in our case, number -1. Now first iteration equals 3, which would be 2, so range of 2 to 2 is just 2, right? So if n of all, for all the range here, if the element, if the remainder of element number n element doesn't equal 0, and so everything in the range has to match this condition, which is that it's not equal, that doesn't have a remainder division of all the numbers smaller than the number between 2 and the number. So if all of them cannot divide the number, then we know it's prime, and we can return the number. Otherwise, we can try to get the next one and just increment by 1. So it will escape here only when it's prime. Alright. So then it returns here. Returns here, then it gets inside prime again. Alright. Okay. And now the escape class for prime, escape catch prime and pn. When the prime number we got is bigger than the number we have, then we know we got it. So we divide the number, our number, and it's becoming smaller and smaller, and we increment the prime number divisor, so it's becoming bigger and bigger, and at one point it will be bigger than the divided number. So at that point we know that any prime number will not be divisible, and we actually also know that the number we divided is divided to a prime factor, which will be the biggest prime number of that number. And so in that case we just return the number that we divided here. Okay, so let's get back to the problem. So if we use the example, we should get 29 here, right? Let's run. Even Fibonacci numbers. I mean, my bad. Largest prime factor. Alright. That's right. So I can call multiples. Call even Fibonacci. But largest prime factor. Nope, undefined. Interesting. I gotta import again. Alright. Largest prime factor of 13195 is 1. So that's not good. Divide by 2 shouldn't work, so I have to go for 3. But 3 also didn't work.
Lieutenant Colonel Vijaykanth, Battigola District Commander. எதிர்பாராத ஏற்பட்ட நேரடி மோதல்ல வீரச்சாவு.
Relax. Debug the end. Find out what is it. And then find out what's the remainder. Alright. Got 2, remainder is 1. 3, remainder is 1. 5, remainder is 0, that's good. Remainder is 4. PN is 7. 0. 7. 6. 11. 13. Okay, 13 remainders. We got 29. But PN is 13. And then it reaches 29. Oh, so escape class can be if they're the same number, right? So this is basically like saying when Pn equals n, but I'm making this guard by the variable. So if a value matches to an n variable, and I say this is also an n variable, so this must have the same value, and only then can it match. Alright. So I think we fixed the bug. And we got 29 here, which is good. But let's see if it works for the big number. Let's remove inspection. That's beautiful. Yeah. So we're calling the function with this number. Then I can't copy it as the latex. Six, 8, 5, 7. Yeah, let's go.